Welcome to Breadboarding. This is video 15 in the Breadboard 8088 PC series, and this is the third video in the series looking at the Monochrome Display Adaptor. So in order to build a basic floppy disk PC, the current step we've been working on for the last couple of videos where we've looked at the high-level design and the detailed schematics for the video controller. We're building out this Monochrome Display Adaptor. So let's just take a quick look and update to the block diagrams to see what changes we're going to be making. This is the main Monochrome 8088 block diagram. You can see here we're changing from using the memory read, memory write to the IO read and IO write for the peripheral interface adapter serial ports, and we'll also be using that for the MDA adapter. And you can see down here that we've actually changed the memory map here so that the PIA and UART are now in the IO range D000 and D100, and we've also added the MDA video RAM in its standard block. Now, although there's only 4K of RAM there, the original PC would have that 4K duplicated through that entire address range, so we probably need to leave it like that for the moment. And if we take a look at the video controller block diagram, this is the diagram as we left it. Again, it's fairly busy, but the only real change that we're adding here is we now have the IO port decoder that we've added in here. And so those are the changes that we're going to be doing during this video. So the first thing we're going to do is to update the main address decoder to switch over from using the memory read, memory write to the IO read and IO write. And this also means we've got to switch the E clock signal over. We also need to add some new chip selects for the Monochrome Display Adaptor RAM, and also putting in a new signal here that indicates when all of the upper address lines are 0 for the IO range. We'll then need to update the nanocomp monitor so it uses the IO ports, and I'll also do is to add code to be able to set the code and data segments in the monitor, so we'll be able to look at the whole address range rather than just the top 64K block at the 7000 range. And if we have time, we'll then start to lay out the display adapter board, and we'll put in the IO port address decoder, the 25 MHz VJ dot clock, and the clock PLD. We'll cover the rest of these items as we go through the next couple of videos in the series. So let's have a quick look at the schematic and the PLD configuration for this first set of changes. So this is the address decoder that we've used previously. Now the main change we're making here is switching it over from using the mem read, mem write signal to the IO read, IO write. This will also change the chip selects for the peripheral interface adapter and the serial port. And then we've also got these two new signals for the MDA video RAM and the IO ports A19 to A12 all being 0. And this is then going to talk to the IO port decoder. So we have the IO read, IO write, and this IO 19 to 12 lines coming in. And this generates all of the IO port enable signals for the various chip selects that we have within this part of the project. The observant ones amongst you will notice that the diagram has changed around a little bit since the end of the last video. I was finding that there were an awful lot of signals coming from the top of the board down to these two PLDs here, so I actually moved the control register from the top here down here and shuffled things around a bit. So it's still quite complicated, but there's a lot fewer wires going from the top up here down to here, so hopefully it should be a bit simpler to wire up. So once we've done the address decoding and got the monitor updated, then we'll also be looking at the clock circuit here. So this is the 25 MHz clock, the clock PLD, and that should give us most of the control signals then that we need as the basis to move forward with the next stages of the MDA adapter. So let's just have a look at the configuration for the PLD. So I've got the current version, the new version, and the previous version highlighted here. So you can see here version 3, we've done all the changes for the MDA video RAM, IO ports, etc. And you can see here that the original memory mapped IO ports in the D000 range is now in the IO port D000 range. So this is an address within a 64K address range. This was an address in a 1 MB address range. And you can see here the pins that we've now used. Two of the unused pins here are now being used for the MDA video RAM chip select and this other IO signal. So we can see here then we've swapped out the memory read, memory write signals for the IO read, IO write. And then an interesting note here is, from reading a bit more up on PLD design and best practices, in general, if you have a signal which is active low, then the recommendation is that you define this with the exclamation mark in the pin definition. And what this means is whenever you're dealing with logic rules further down, you only have to worry about whether something's true or not, and then the inverting of it just takes place in the pin mapping. So this is a bit of a change from the previous version here. But what this means then is whenever we're dealing with any of these signals in the logic rules below, we're only ever worrying about whether something's true when it's 1. So that simplifies things a little. So you can see here, these are the two new signals for the A19 to A12 and the MDA RAM. Then the E clock signal, again taking it on board this inverting rules, now means that in fact the E signal is based on the IO read and IO write, and in fact because of the way how we're inverting IO read and IO write in the definition here, then we don't need to include this invert here, so it does simplify things a little. Then in version 3 we've now changed the peripheral interface adapter and the serial port, COM port. Now the address range has changed slightly, so we've had to change some of the conditions here, and we've also now included the IO port rules associated with that as well. And then we've also got our new MDA RAM and the other address signal down there. So those are the main changes we need to make to the PLD, and then we'll also need to go in and make quite a few changes to the monitor assembly language to actually work with these changes. Okay, so we're just going to make sure this is still working before we start making the changes. That's Nanocomp 8088 version 2. And if we just go memory 0, 01, 02, 03, go back to memory 00, that's 0, 1, 2, 3. So we're able to store data and resets working. So what we're going to need to do here is we're going to swap out this PLD for the one I've just programmed here. So this is the V3 version, which is using the IO read and IO write rather than the memory read, memory write. We're going to have to wire in the IO read and IO write from here round to here. Now at the moment, the RAM and the ROM is using the two lines here, which are currently memory read, memory write. Now these are going to become IO read and IO write. So what we're going to need to do is to add an extra bus at the top here. I'm going to put the memory read and memory write at the top here, and then these three lines here, so there's two memory reads and one memory write, are going to need to go round up to the top there. But because these ones down here are going to be changing to IO read and IO write, then I don't need to change anything down here. And then we'll put in the new EPROM with the version 3 of the monitor and see whether or not that works. So I'm just going to wire this up. When we come back, we'll be ready to switch on and see if it works. Just plug in the new bus rail, which will be memory read, memory write. Take out the old PLD and the new program version. Now we're taking out the memory write and putting in the IO read, IO write into the PLD. And then we're going to have to wire up the memory read, memory write up to the top of the board there. Now we need to unwire the ROM and the RAM from using the lower bus rails up to the new ones at the top there. So that'll be memory read and memory write put in there, put in new ROM. Okay, so I've updated the monitor and the PLD. We've installed all of the IO and the memory read, memory write. So the IO is now down here and the memory read, memory write's up here. You'll notice I've got some of the logic analyzer plugged into the address and data lines. There were one or two minor issues that I had, which I'll explain. I'm going to go through the code. So if we now switch it on, we should now see Nanocomp 8088 version 3. So this is the code now, which is using the Intel IO ports rather than the memory mapped PIA and serial adapter. And if we just go and see 00, 01, 02, 03. So yeah, so we're able to save and things. I need to do some more testing on it. There are a few updates as well I need to do. What I have also done is set some new commands. So one that I can do the E segment. So I can put in an E segment value here. So if I wanted to load data to 1000, for example, and there's now also a code segment as well. So if I wanted to set the code segment to 100, I can do that. And it means now when we press go, if we do load, save or memory, then it can actually move it to the different memory area. So if we go 000, then you can see now that 000 is now not got the same information in it because we've set the extended segment to a different value. If I go back and set it back to 700 again, so if we go to E7000, memory 0000, and you can see here the values that we put in there. So a few changes there, but it's working okay for the moment. There's a few sort of tweaks and things I need to do, but I'll do that in the background. So just have a quick look at the changes that are made. So these are changes to the monitor. I have version 3 on the left and version 2 on the right. So the primary changes that I've made: convert to use IO ports and setting the extra segment for memory access and code segment for the go command. So those, rather than being hard coded to 7000, which was the top 64K of the 512K RAM chip. So we've added these E and C commands. The ports have changed for the serial port. They're now at port E000. A few changes around the stack, which I'll go into in a future video. And then the PIA port is now at D000. And I needed to make a small change to the PLD configuration for that. So the way how these are now initialized, in that the code segment default value is set at reset and the extra segment is also set at reset, and then after that it will then be changed by those commands. So just writing the nanocomp version number. So now adding the stack pointer to the register display. There's a few issues I need to sort out on that, but I'll work on that in the background. Again, some stack pointer related things. So this is the key handling in the main loop for the extra segment and the code segment. Again, some more stack changes. Then this is the new code we've added to set the extra segment and set the code segment. This is the code where we've had to make changes to the IO ports. Now, if we have a look at the output and input, so again, we can only use AL if we're doing 1 byte at a time, which we really need to do with the way how the 6821 PIA works. So you only want to do 1 byte at a time. Therefore, we have to use AL, and so that's why I needed to change quite a lot of the code. Unfortunately, when I made the decision for converting 6809 to 8086, I mapped A to AH and B to AL, and in fact, because of the IO ports, I need to swap those two around. So a lot of the changes have just been related to swap these around. And then the way how these instructions work is we set the IO port in DX, we put the value in AL, and then we do an out command. And then when we get to the get key, an in instruction, so in this one we're getting the port in DX and we're reading it into AL. So the majority of the changes have just been related to do that. The only real issue I had when I first ran this is there was one bit of code where I'd not swapped the AL and the AH around, and so one of the loops wasn't working quite right. But other than that, then this didn't take very long to get up and running. So now we've got the monitor running and it's running with the IO ports. We should now be in a position to be able to lay out the initial part of the MDA board. So we've done these first two items, and if we've got time for the end of the video, I'm just going to lay these out and to wire these up. We won't do very much testing on this during this video. We'll wait until the next video for doing that. Okay, well, I've trimmed the surplus power rails off of these breadboards. They come with 2 power rails each, so we don't need some of the power rails there. So I've got the breadboard buddy in the top here, and this is the Gravitech VGA connector. So this is a sort of little thing with comes with the pins to solder in there, so I just need to solder those pins into there, and that's what we connect onto the VGA monitor. And so I've laid these out. The things we're actually going to be focusing on for the rest of this video is the IO decoder, the clock crystal oscillator, and the clock PLD itself. All I've done is laid out these other ones. So this was the dual port RAM, this is the character latch, this is the CRT status. As we already said, this is the IO decoder, this is the character ROM, the shift register, this is a CRTC controller, and then we've got our VGA digital analog converter, the clock, as we said, the oscillator. This is our attribute latch. Then this is the CRT control, and then we've got the video out PLD, the attribute PLD, and then I had to move this over to here. So this is the blink clock PLD as well. So I think this layout will work fairly well. So I'm going to take the rest of these chips out. I just wanted to make sure that everything would fit where I was going to put them. And so they're just these ones here. And then we're just going to wire them in. And then once we've finished that, we should be done for today. Okay, just take out the unused ones for the moment. Plug in the ones we're using. Just going to put in the power rails for each of the chips and for the oscillator. And for the oscillator, we're going to wire in the 25 megahertz output and just make sure it's in the right pin. Then we're also going to ground a lot of the leads around the oscillator to prevent any stray 25 megahertz signals getting onto any of the other tracks. Okay, so we've completed these steps in our Monochrome Display Adaptor activities. So we updated the main address decoder to use input-output rather than memory-mapped I/O devices, and we also added a chip select for our MDA video RAM and also a line that indicates when all the top A19 to A12 address lines are zeroed. We also updated the nanocomp monitor to use the I/O ports, and we did a few other enhancements as well. And then finally we've just added the I/O port decoder, the 25 megahertz dot clock, and the clock PLD, for which we'll start the next video by starting to test that. So in the next video I'm going to test that these bits are working, and then we're going to install the video RAM, cathode ray 2 controller, digital analog converter, and the 15-pin VGA sub-miniature D connector, and that should allow us to do enough software to be able to test the initialization of the CRTC and the video DAC and get some basic video output. Just some sort of broad bands of different color should be possible with that. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you can hit like, it just helps to make the videos available to a wider number of people. Thanks for watching.